So what you doing with the shuttle? Yeah, that's actually what you usually work. Which one? Yours is probably closer to the right?
Yours is the max. Mine has the best, so I'm not sure if mine But anyway, this guy was a really good person.
Yeah.
He had a series on my own.
That's cool. Remember it typo for taxes? Oh yeah. Well, that's what these are. It's like here is very well. It's like here.
You're gonna have one person remote control the Zoom session, and your whole group is gonna go up to the front. You might want to figure out how to do that remote control. So when you connect to the Zoom session, whenever you share your screen, you can share it with the option to allow that one to remote control your computer. Somewhere in there. We can switch them around if we need to.
Oh, so you didn't get her. Just kidding. It's like, what would that be on? You just do
No, I understand.
so instead of writing it out, yeah. So instead of writing it out, something like we did, and just set it to showing this number.
Yeah.
Import it.
What output did you get? What's that?
Right there. Yeah.
She wants us to match
They have more
We'll go first.
Okay, great. Remote control.
Probably.
You joined the
Yeah.
yeah, I just joined the band last night. I was like, oh, it's pretty cool. And you're the only one to.
You said you did it.
I'm wrong, and other Christians are wrong.
Because it is not under a band. It's not under a band. Is it whiteboard?
You can just request and then that way when you're up there, you will start to come back and you click on it.
Just so you get teacher access.
Yeah, I've heard it. Auto access. So let's start here. Nope. Nope. All right. The motion's do it like this. I can now click the screen. Does it work?
Yeah, it says you're controlling for resolutions discussed.
That's okay. We don't care about that. So good morning. We are group 2. We're the only group that sits on that side this morning. Our main we didn't have to touch. So then we come into the driver class. Starting out, we have right there. Right there is our overload. We overloaded the class so that way we can have a 5 input and a 1 input. If this is a real world situation, we would have a lot more input possibilities. And then we have the 2 methods that it uses. It uses the calc average cost and then the toString method as well. If you look, we formatted our outputs to have a certain amount of spaces. And yeah, any questions, comments, concerns, or fish? Fish. Okay, we're good. Anything you guys want to say?
Do you want us to talk? What do you want us to talk? Else to talk about? Right.
You guys are short and sweet, that's fine. Do you want to look at your driver class?
Yeah, that's what we're looking at right now. Is our driver class.
Not too much for you guys to say. Anybody have any questions for them?
In my case, I kind of scrapped my main. I got into war with my code and decided I'm just going to redo it all. So my main looked completely different from yours, or probably one of you were given as well. All 3 of ours were completely different.
Were they?
Yeah.
Yeah, I scrapped my entire thing.
That's good. Okay, everybody, give them a hand for the Lord first. Yay. We're on 620. We're okay with that. Okay, you guys, we use that stream.
Yeah.
This one and then up on that bar. I like
Yeah, I didn't know. I just quickly come through.
So go back to the computer that you're sharing from, and then there's going to be a view options at the top. How are you going to do it?
Oh wait, hold on, I have to request it. Hold on. Yep, sweet, okay. First, good. Martin, would you like to go first? No. Okay. Well, Greg, you're next.
All right. I'll be explaining the get and set methods. We have our list of variables right here, and they're all set to private. So we have to be able to get the numbers and then return them to the main. So we use these get sets, which will pull the value from the main to set those values into there so we can run our program from the driver class.
And I was more responsible for whenever our main calls for a new driver, that it's understanding what it's pulling from and what numbers it's trying to get and set, making sure that it's pulling from the right driver class and then getting all the numbers where they need to be.
And a lot of you may be thinking it's like that wasn't necessary to begin with. What we did was originally we changed a lot of our variables and method names to match something that we just kind of worked on. So as far as like using the different ones, an important thing to remember was to make sure that those get changed. Whatever it says like driver to dot and then whatever it's calling, that matches up exactly with what you've set as a custom one in the actual driver.cs as well.
I was responsible for researching a system with the correct usage of parameters and method usage for the separate sections. So this is example.
Now, the main section where that kind of took place was especially whenever the actual public driver was sent out.
Try to.
So if you look at line 48 and 49, or 48 through 55, I guess, that method right there, what that does is ends up calling through all the actual variables that we've set with the mutators there, and then making sure that it instantiates them for that specific driver. And then that's where my job kind of came in, is that I was in charge of making sure that the if statements were working appropriately in order to make sure that it's changing the information for that particular driver itself. So that object is being changed alone and not necessarily changing like Scott or Tony's number separately, which of course would end up in a wrong output. Now, one of the, I guess like the main difference you'll see between like our group and the group previous, I guess you guys did a lot of the stuff in like the same method itself. Or
Yeah, so we had one method and then we had a couple functions inside of it. I mean, one class with a couple of functions inside of it.
Okay. Yeah, so the reason why we kind of chose to go with a lot of separate methods here, hence why it seems a lot more intimidating or longer, it allows you to kind of pinpoint any sort of errors. So if something does pop out and you're not necessarily needing to look through several functions in one method, you can actually pinpoint the error itself to one particular method itself. The nice thing about this is that although it is a lengthy process, it allows the actual program to, I guess, like run almost incomplete, which at one point, so if something does fail, it'll let you know which part fails, but then the rest of the information will still be accurate and unaffected. Okay, that's ours. Do I need to do anything here, or just stop sharing back there?
Okay, stop sharing back there.
Any questions for them before they run out? You got it. You got it. Thank you.
So,
Plus your
You guys can get some credit. Well, I don't think you know. Well, I want to hear it.
Well, we'll let you do it from here. Might have to.
see something.
Okay, we're gonna fix that for a
They're doing it.
there you go.
Oh, there it goes, kind of.
Yeah, we go. Okay. So we have group 4 and here project line. The first thing we want to talk about is how we solve the problem. So based on the requirement, based on the test code of the main, so we can see that we have some variable we need to declare, and based on the content of the assignment, we can see some we have some fields or some variable we need to declare. Right here, we use the private variable for all of them, so we can make sure that we can encapsulate this on variable inside the class. And then we use property based on that field. Inside the property, for each field, we have some testing methods to make sure that the property input property line with the name, to make sure that it need not to be an empty name, so it should be has length greater than 0, and also we have some rank or some other integer. We need to make sure that it's greater than 0, like this. Rank here, rank car number, make sure on better than. If something happens, we need to put an output control, so make sure that people know that they put the wrong one, so you can fix it. Yeah, and then next step we're gonna do some constructor. The constructor is built based on the the testing code, we had choose new object right here. The first one gonna get all the parameters like name, range, number, and everything in the first one. And the second one, just the name. So by that idea, we build the training constructor technique. So we build the first one is the master constructor right here. We include all the parameters inside one, and then we build each separate constructor based on the requirement. Here, like this one, the first one is the default constructor. And the second one will be the second constructor with the name. And the method we have right here, we have two methods. The first one going to be the toString method, and the second one is calculate the average cost methods. There are the group this. Now group we have the first when we met with this the problem, we met two main issues. The first one is going to be the toString format, because at first we don't know how to use a string dot format. We didn't know it. We tried to override it and just bring it back, it doesn't accept it. And with string dot method, we can convert any type data into string with very simple side like this. I think on the groups did that.
Yeah, that's an issue I had with getting it to output the proper pricing format.
Yeah.
And figuring out how the properties work. That's what I had a problem with.
Yeah. And so I think the most challenging thing for us, for me, I don't know, for me, like the that one, the string.to format, because we didn't know it, and then the instruction, we got that idea, and
Yeah, the properties and all that.
yeah. Then yeah.
Hey, nothing to add. We'll print this one out and post it on the wall as an example of perfection.
I really like the hair.
Everybody's so good.
I really like the hair.
Yeah.
That's how that's the only thing. It's like,
Get a new camera too.
yeah. I have two young.
We
Just have one brief
have a power supply.
Yeah.
That has a point of control. That's still from
This is the driver. First things first is declaring the variables that'll be used in class. So we got private string name and all that. So it'll be global within the class driver.
Yep. And then we want to get our getters and setters and use them for the variables. So get over.
And then this is us, again, like how we got the average for like the total amount spent by the driver. And then a little bit more down, we have how we formatted like the output and such. And that was like a big, that one was hard to do. It's hard to get all the spacing correctly. And that's all.
Pretty much it.
figure out how to leave this Zoom meeting. I don't know how to do that.
All the better trained.
And then in Discord, they have the voice channels that you can get into with the groups.
As we lead.
You guys want to stay with your groups, or do you have to go back? It's up to you. You're already sitting.
Too bad.
You're already sitting. I'm so steep here. Let's do some practicing.
We try.
Do you see the announcements Monday? We'll start moving across the hall. I think they've decided that there's like a separate exhaust system in the middle of the building versus the outer edges. And so they think that I'll survive better over there. It's a nice room, so that'll be handy. As far as I know, yeah, we'll see. It should be permanent. I never know about anything. In Canvas, before you can get to lesson 7, you have to complete this open unit 2 thing in there, and then that should open up everything for our unit 2 stuff. If it's not letting you get to it. And we're going to look at this special PowerPoint over decision making.
I mean, she does say 24, 23 years. So I think we can actually start.
I'm just going to get that one off Canvas to make sure I've got the same one we're looking at, because you know how that goes. Let me download it. Come on, you silly thing. I'm getting there. Somebody's got it all switched around. This work. It's up to you. You can submit it. That'd be great. If it'll let you. If it'll let you. Sure. I'd love to see it. We're finally done with all our structure stuff. You guys have been working hard trying to understand big concepts as we pull all the pieces together. And we're going to look at decision making, and this is going to let us pull a little bit more together. Now, we saw some decision making in chapter 4, and that's where our book talks about it. There's not very much, and that's kind of where we'll be too. It's just sort of a logical thing that we need to know how to do in C#. Remember, they call it selection statements. I don't know why I think decision statements was just too easy. Can't have easy things like that in programming, or everybody will be able to do it. We want to make sure that we keep slackers out. But why is an if statement a selection statement? Because we're selecting what code to execute based on the outcome of our decision for our if statement. So we can use them to control the flow of our code, the logical flow. We can have certain code that gets executed if our decision is true, and other code that could be executed if a decision is false, and we can control things that way. A single selection statement would be a single if statement. So this is an example of a single selection. We're saying if the color is violet. Now that gives us a little bit of a hint to the C# structure. If you notice, this if statement should have a lowercase I, but you know how PowerPoint fixes everything. So anytime you see an if statement, no, it should be a lowercase I, and it probably got uppercase on me without me noticing it. But other than that, it's a valid if statement. The condition part has to be enclosed within parentheses for C# to understand it. So if I were to execute that if statement and I had this collection of data here, it would only be the violet ball that got chosen or got processed by the code in the if statement body. Single selection, because there's only one way something can be selected. Only if that if statement is true would I execute the code in the if statement body. So here's our syntax for C#. And just like the other stuff that we've been learning, it's all enclosed within curly braces because we just love them. So whenever we're doing an if statement, the keyword is if, and then our conditional is within parentheses. So that doesn't matter in our conditional if we have 47 or statements or whatever, it's all enclosed within a set of parentheses. Then we have an open and closing curly brace. In our if statement body, the code that gets executed if the if statement is true is enclosed within those curly braces. Now, if we only have one line of code that we want to execute if the if statement is true, we can get away without curly braces. So one line of code, no curly braces. We can do it this way too. A lot of people like to write their if statements this way, which is perfectly fine. If statement, and then the one line of code that is their statement body right there on the same line. We'll see lots of other syntax too, but that's the main syntax of an if statement. So you guys have just been doing awesome at keeping your curly braces straight. I've been really harping on that from the very beginning because it's caused so many people so much trouble over the years. So good job, keep it up. Now that we add another structure in that requires that beginning and ending terminator, it can complicate things a little bit more. Now, before we think about logically using if statements, remember a decision-making structure is usually considered to be the diamond in a flow chart, and we usually think of two paths, the true path and the false path. And in the 120 class last week, they were drawing flow charts, and someone drew a flow chart with about 7 paths coming out of the if statement. We can potentially do that with a select case statement, but it would be drawn a little bit different. But in general, we want to think of just the true and the false path, because that's going to keep us logically what's going on. So we're either going to be true or false. That's going to be our Boolean result. When we're working with C#, our relational operators, our comparison operators, is less than or equal to, is greater than or equal to, is equal to is the 2 equal signs, and is not equal to is an exclamation point equal sign. And at the Microsoft conference I went to a couple of years ago, all of the Microsoft people would say, and it was really weird, I don't know, it's in Vegas, you know, people talk different out there, they would say bang equal at. That's what the exclamation point, the bang character, which I've heard it referred to that in other ways too. So our test condition, whenever we're doing a test condition in C#, it's going to be much pickier than, say, Python. Python gets pretty flexible with its if statement structure, and it's like, oh, you want to say if 7 is 45 or 46 or 49, sure, that's fine, I'll let you do that in Python. C#, not so much. It's going to be much pickier about having everything formatted exactly the way it wants it. So in general, we have to have a left operand and a right operand. Is A equal to B? Those operands could be variables like X and Z, or they could be, you know, like a number, like 42, or whatever we want in our if statement. Just remember that we usually have to have the left and the right operand unless we're working with a Boolean. So
When we're working with equality, always remember the two equal signs. And they try to trick you on all the different programming languages with this. One equal sign is an assignment statement. You've seen that already. Two equal signs is a relational operator. So if I just have one equal sign, I'm setting a value. So in this line of code here, if I accidentally made that only have one equal sign, I would be setting the variable stoplight equal to the value red. I wouldn't be doing a comparison at all. So my results might be kind of ambiguous. In the IDE and Visual Studio, has gotten smart enough to kind of warn you about that sometimes. Now, whenever we're working with setting up our condition, remember that the order of your operands may not make any difference at all. Sometimes it does, sometimes it doesn't. So if I'm working with an equality comparison, it doesn't matter. I could have red on the left or on the right. I would get the same result. Now, if I were working with greater than and less than, I would have to be more careful. And remember when we're, oh, I can't talk right. Whenever we're working with decision-making structures, we might have to add additional test data because we want to make sure that we're using test data to test every possible condition of our if statement. So the true conditions, the false conditions, and then just totally invalid test data so that we make sure our error checking is good. Now, if we're using inequality operators like greater than, less than, different things like that, then we do need to be concerned about the order of our operand. The most important thing on this slide is the little note in the green box. There is no semicolon. And so if you have made that mistake as you were working with the REPL and copying that code to do the data validation, you've seen that it can have a really bad impact on your results. So anytime we have a body, open and closing curly braces, we don't have a semicolon. So those single alternative selections, we only have one way of doing things. What if we need more alternatives? We need to check more than one. Well, we can add an else clause. This becomes a dual alternative. It's kind of a silly way of saying it. That's what the textbooks love. First alternative is if the if statement is true. Second alternative is if it's false. I'm giving you an else statement body. So we're saying if this condition is true, execute the if statement body. Otherwise, execute this else clause body. So either way, one of those things is going to get executed. The else clause, if you notice, starts with the keyword else, and then it has an open and closing curly brace. And again, all of the code that we want to execute if the if statement is false has to be within those curly braces. If we only have one line of code in our else clause, we can leave out the curly braces. Some people like to include curly braces no matter what, just for clarity. And because they say they usually add another line of code. Some people hate curly braces and will leave them out at any cost. So totally up to you. It'll work either way. So when we're looking at our if statement, we know the code path is either going to follow the true path or the false path. We can go even further, though, with multiple alternatives. We have a couple of options for doing that. First of all, we can use the else-if construct. Let's take a look at it. When we're using an else-if construct, we have to start with the if statement and then the if statement body. Then we have our else keyword followed by another if statement, and then that if statement body, and then another else statement followed by an if statement. And finally, at the very end, if we like, we can have one final else clause that is executed if none of these if statements produced a true result. Where I'm going to see something like this as a code, right? So like if my code is A, do this, else if the code is B, do this, else if the code is C, do that. Biggest syntax problem that people have coding the else if clauses in C# is leaving off the expression on their else if. So whenever you have that word if, you have to have an expression. If you don't need the expression, then you should just have the else clause and just do the catch-all, get everything else, okay? So that's how we work if we want multiple alternatives. But we do have another way, and this is the select case statement. So here's a flow chart for it, because I was kidding about having multiple lines coming off the decision structure. Can't do it no matter what. And here is how we would do it if we have these multiple conditions. We're inputting an age, and then we're checking the age. Is the age greater than or equal to 21? If so, we're going to output this message. If it's not, we're going to check to see if the age is greater than or equal to 18. If so, we're going to output that message. Otherwise, we're going to check to see if they're greater than or equal to 16, tell them they can drive, and in the last resort, we're going to say, oh, sorry, you're too young. We could support this structure in that else if structure that we just saw. But we could also do a select case. So here is some code for it. We've got else ifs and if statements. So look at those and notice the difference. I don't have a select case here statement here yet. In this example, the if statement is followed by an else, and then each else clause has another if. Notice how the structure is kind of going across, I guess is how you could put it. And then over here, where we're using the else if, we have a flatter structure, so it's less complicated for another developer to look at and understand. In the end, it's going to probably do the same thing. I'm not going to sit here and go through it, should, but we have a much easier to follow structure over here using our else if clause. And then the easiest to follow is the switch case. This structure can also be kind of something that new programmers are hesitant to use. So don't be that way. This structure, according to some research that I've done online, is actually one of the most efficient structures that we can use when we're doing selection like this. Because what we're doing in a select case is saying, check this certain variable. If this variable is an A, do this stuff. If this variable is a B, do this stuff. So we can have some direct branching going on internally to what structure should be executed based on the specific value. So it's supposed to be more efficient. So let's look at it in code. So here's some switch case code. So in this first example, we've got a variable named stoplight, and it's a string. And right now we set it to a value of red. That doesn't really matter very much, but that's what its value is right now. So the C# code that we want to look at is this switch statement. We start with the switch statement, and within the parentheses of the switch statement, we specify a variable name. In this example, we're saying, look at that stoplight variable. Then we follow our switch statement by multiple case statements. So we'll say, in case stoplight is green, do this. In the case that stoplight is yellow, do this. In the case that stoplight is red, do this. And if you don't find any, do this default value. So in our example, we should get that output message written out that says stop.
On the case code, the arguments have to be in parentheses. Because on the left, most of them are. On the right, most of them are.
Why would that be?
Are you asking like a question to make me think?
Can you see a difference?
Well, I don't know if they run or not, but like the one about the stoplights, the green and yellow arguments aren't in parentheses.
Right.
And then all the other ones are.
And like the red is. So you'd have to try it.
Or not?
Over here, we're looking at ranges, so we for sure have to have the parentheses. Whenever we're looking at that string value, we'd have to try it. and see. I think that code is okay. You know, I think that it runs okay. But yeah, we definitely would have to try it. And so we have to have the parentheses over here because we're doing a range. So in this example, we're looking at the age variable, which is an integer. And so in that case statement, we're saying if the age is within the range 21 to 150, we're going to output some things. And we have all these other ranges then that we're going to use. So we can do that instead of those if statements that we were looking at earlier. So we'll try some. Uh-huh.
If you value a case, can you next switch cases just like that?
Uh-huh, you sure could. So we could have another one inside there. That's a good question. Let's see some other things. You have to have this break statement at the end of each case. And if you don't, C# will complain at you. Like, if you were using some programming languages like Java, it would just fall through and evaluate other cases, but C# won't. It'll say that the select case statement is invalid if it doesn't have the break statement. And what the break statement does is break out of the select case statement and continue executing after the closing curly brace of that switch statement, so we can see what's happening there. Let's try some. We don't have a lot of code. Oh, we have wait one more thing in this presentation. The ternary selection. In this example, we have a flow chart here, and we're just asking if the sun is shining. And if the sun is shining, we want to go fishing, and if it's not, we want to just hang out in the cabin. So we have an if statement with two possible actions, right? Our true and our false. So here's how we can handle that in our code using a ternary if. In this right line statement, we actually have it embedded. So we have our ternary if being our Boolean variable, sun is shining. If the sun is shining is true, we are going to output this go fishing message. Otherwise, we're going to hang in the cabin. So when we're doing a ternary if statement, we're looking at some sort of condition, like this Boolean variable here, sun is shining. Then we have a question mark. The data following the question mark is what is done if the if statement is true. And then we have a colon, and the commands after the colon are what are executed if the if statement is false. Our compound expressions, if we want to do ands and ors, the ampersand is a logical and. The pipe symbol is a logical or. We have two ampersands being a conditional and, which is a short circuit. Talk about that in a second. Two pipe characters be a conditional or, which is a short circuit. And then we just saw the question mark colon gives us the ternary conditional. Okay, a few things. First of all, where's the pipe character on your keyboard?
It is above the enter key on the right hand side.
Yep, shift above enter. Do you see it? Because you may not have had to use it for anything before. Sometimes people are hit by that. And then what does the short circuit mean? It means that C# can stop evaluating the if statement if it's already decided that it has to be false, basically. If I have an and condition, I say, if A equals 1 and B equals 2, and C# evaluates A and says, nope, it's not equal to 1, there's no reason to continue evaluating that if statement, right? It's done. We know it's false. So that's what short circuiting is of an if statement, is instead of continuing on to execute all of the different logical operators, if we find some sort of operator condition that makes the whole thing false, we'll just stop. And that can save a lot of execution time depending on what's going on.
How does that work before?
If one of them's true, because then you know, oh, one of them's true, so don't need to go any further. So, good question. Being backwards there. Okay, and then range checking We sort of saw it with that select case statement where we could say, is this within a range? But I wanted to kind of bring out some important points. Here we have a variable age, and the age variable is set to 14. First of all, this if statement has bad syntax. What's wrong with it?
It doesn't have a body to go with it.
It's mad about that. That's what that red squiggly is at the end of it. What's wrong with the condition itself? Right, so I can say if age equal 14 or age equal 15, but I can't say if age equal 14 or 15 because C# doesn't know what variable I'm checking to see what's 15. So I always have to have the left operator and the right operator. And yes, it's mad about not having curly braces after it too. It's really bad. Okay, let's see, let's check the next one. What about the stoplight one? We've got our stoplight variable set to green. And in our condition, we're saying if stoplight equal green and stoplight equal yellow, you may proceed, else we're going to stop. What's going to be output there?
Because it can't be green and yellow at the same time.
Right, so they probably meant to put an or condition there, and they used an and instead, and that's a real common mistake that we can run into, even with super experienced programmers. It's just common to make mistakes like that. Okay, what about this one? We have our age set to 14, and then we're going into this if structure. What's going to be output from that? Is it right? Does it look like it's all going to work right?
Yeah, well, the issue though,
That one looks
because
good.
the input will make it print out too young, but with how it is, if you're 21, you put it in and it'll only say can drive because it'll evaluate only the first statement.
So that would be a problem. So where we are exactly, the test data we're using, it looks like everything's good, but in reality, we would have a problem if we were testing it with all of the test data that we need to test it with, because then we would see that we don't have things in the right order. So what order should we put those in?
So we can either change the operators, and I can't think right now which one will make it work. Or we can just switch the order and put the oldest one first and go descending from there.
Right, and it's logical that way. You're right on it. Since we're working with a greater than condition, we would want our greatest at the top, right? And then that way we would always be evaluating the highest one first. And as we worked our way down, we would want to check for greater than 21, then greater than 18, then finally greater than or equal to 16, so that we would be in the right order. What about this one? Here we've changed it, and now we're saying we're doing some ranges here in the if statement. What kind of message are we going to get output from that one with our test data of 14?
It's going to be the first one. The second condition is age is less than or equal to 21.
Right. So even though that's not what we intended, probably,
Should be and.
it should be an and. We're going to accidentally make that mistake that we're going to catch everything there, anything that's less than or equal to 21.
Also, the first one, the condition needs to be changed because it's the same as the second one. So that, so the first one should be if age is greater than 21.
Instead of less
We don't need
than.
a range on that one.
That would be right. So our or conditions can really, really cause us trouble. Anytime we're using those logical operators, we can get into a mess. We just have to really be careful. And we want to make sure we're using all of the test data that we need. So again, that truth table, if you remember it from the 120 textbook, they had that truth table that was really confusing. And what they were saying was, you want to make sure you're testing with all of the different possibilities. So we want to make sure we're trying a green light and a yellow light and all of those different conditions that we need. in our program. And then when we're working with selection statements, if statements, we do have an order of operations. Just like when we're working with math problems, it's a little bit more complex. So let's think about it here and try to simplify. What's a unary operations?
Simple addition, subtraction.
It tells us, luckily. So first we got to do the math. If somebody embedded some math in an if statement, we've got to find the answer to those math problems first before we can do anything else with that if statement. Then we need to make sure that we're setting not conditions, negative issues, things like that. Then we're going to multiply and all the math stuff. Finally, we're going to check relational operators, greater than, less than, then equality, then logical, our conditional ones, and our ternary, and finally, we're going to evaluate any assignment statements. So you can make it a goal as a developer to get all of those things in one line of code if you can. And then we'll all say, no, don't do that. So anyways, when we're looking at decision making, remember this is the heart of things. If we didn't have decision making, we couldn't have any software development, and because we wouldn't be able to make any sort of logical decisions based on any sort of issue. We wouldn't know what to do about anything. So when we're working with C#, our structures are if else, if else, the switch statement, and the ternary operator. So we're going to look at some different practices to try some things. Let's open Visual Studio real quick. I'm going to create a new project, and it's going to be a console app. And it's kind of, I feel like our content here is just kind of floating out in the world because it was sort of in chapter 4 in our textbook, but we're kind of in lesson 7. I'm just going to say lesson 7. The first thing that we do, let's do in the presentation some of the sample code that we had. Was this can drink and drive and stuff. So I'm going to put age selection. And I want the solution name to be something a little different. I'm going to make it be lesson 7 selection structure testing. So for our program, we're going to do some right line statements. I'm going to go ahead and put in my using static statement. Let's rename this program.cs file since we're going to have a few projects in this solution. I'm going to rename this to be age. And I'd like to rename that class too, so that we're all in good shape. So in our first example, we just had an integer named age, and we started out with it set to 14. So you guys have gotten really good at using the console to prompt people for input and to output things. And as we move along, we'll be doing a little bit less of that. We'll be doing more just putting values in the code that we want to test with, because we don't need to spend all that time to write those methods to prompt for input and all that stuff. You know how to do that. So we're going to set up this integer with an age equal 14. So let's just put a simple if statement in, and let's say if the age is less than or equal to 14, what do we want to write out? This is going to be a special one, a little bit different than the others. Being a teen is tough. Do you remember that, thinking that? Now you know. Let's do some other labeling. Here is the end of my if statement and the end of my main method, end of my class, and finally the end of my solution. So you remember it's Control F5 that you can use to make the console stay so that we can see our output. So the way we have everything set, we should see that output message. And there it is. I've got my output message. So that's just our simple if statement. So let's put a comment up there. This is a single selection if statement. Now I'd like to try another one. So let's see if we can do some things in this project without creating a new one. If we can have multiple mains, I might get it all messed up. But let's try it. Go to your project in Solution Explorer, make sure you're on your project. And on your project, right click and choose Add Class. And we want to add a class age driver. Now I've got two classes in my project here. I'm going to add a main. Let's see if we can handle this with two mains in one solution. I want to update my using clauses again. And let's set up our test data. We're going to use an integer named age, and we'll start with it equal to 14. Now we want to start again with our highest value, whoops, greater than equal to 21. So if they're greater than or equal to 21, they can drive, vote, and drink. Please drink responsibly. Now I want to see if this will run, because I've got these two mains in the same project, and I might just make Visual Studio furious at me. So I'm just going to right click here on this new one and see see if I can run it. I don't think I can. I used to be able to. Sometimes the new stuff. Yep, it's mad at me. Program has more than one entry point defined. So I could do something to specify which module has the main, but that'd be silly. I'll just create another project. Okay, so stay with me. On my solution, instead of using the project level, I'm going to go up to the solution and I'm going to create a new project. Add new project. And I'm going to make this one be age driver. And then I want to copy the code from that one that I was working on. Now, when you've been working with Visual Studio, you know that it has a lot of features and a lot of capabilities. And the last time I did this, like somebody left the room crying or something, so I don't want to overwhelm you. But if you right-click on your tabs, you can actually make like vertical tab groups if you want to have tabs side by side. Nobody's crying yet. Huh? Okay. So I'm not going to do anything with that. I just want to show you that you can, in case you want to. Now, what I want to do is my age driver class that I'm not going to be able to use, I'm going to go ahead and copy my little bit of code out of my main. And then I'm going to delete that from my old project because it was making it mad. Then I'm going to go to my new project, my program.cs, and I'm going to paste that little bit of code, which I could just type again too, either way. Okay, so now I'm in my program.cs for my new age driver project. I need to fix my using. Okay, so is everybody okay? Got all the pieces there? Let's put an else statement in. In our else clause, let's just output a message that says cannot. Now with our test data set at the value of 14, that's what we should see, is that cannot message. So if I press Control F5, I see my being a teen is tough message, which reminds me I need to change which project starts up automatically. So I'm going to right click on my age driver and set it as the startup project. And Control F5 again. And now I should see my message that they cannot do anything yet. Okay, so this one, the reason I want an if-else statement, this is dual selection. If our if statement is true, we execute the if statement body. Otherwise, the else statement body. And we really want to think about all of these different if statement structures so that we can use the correct one for what we're working with. Now this program.cs, I want to rename it before I go. Let me rename it age driver. But I have the rest of the project. And then I should be ready to leave that one so that I can return to it later as an example. Okay, so we want to create another project. Add a new project. This one, we're going to do the age if else. I'm going to roll up the other projects in Solution Explorer to make sure I'm only looking at this one. I'm going to make it my startup project. And I'm going to rename the program.cs to be age if else. Then I want an integer named age for my test data. And we're going to start out again with our age greater than or equal to 21. I'm going to fix my using okay, so if they're over 21, they can drive, vote, and drink. Please drink responsibly. So our next condition then is if their age is greater than or equal to 18. If so, we're going to output can drive and vote. Please vote responsibly. But we have another condition. So we're going to add another else if. And this time, we're going to see if their age is greater than or equal to 16. And if so, we'll say you can drive. Please drive responsibly. And then finally, if they're outside of all of those conditions, our final else clause will say, sorry, you are too young. Now, some common things that I've seen people do, and in one thing, using REPL, since it doesn't help you guys indent, I know it kind of tends to make it easier to just put all your code over at the left margin and not indent, where Visual Studio is really helpful with it. You can see where indenting correctly starts getting really, really important. Because if we're not indenting properly, if I have this kind of all janked up and stuff, it can be really hard to tell what's going on. So this is our convention where within an if statement, actually within any curly braces, opening and closing, all of the data inside that curly brace should be indented to the same level. So when I'm looking at my main, everything in my main should be indented inside the main's curly braces. When I'm looking at my if, everything in the if and else should be indented inside those lines of code. So again, Python forces you to do it. C# doesn't, but we still like to have that good convention of making sure everything's nice and clean. All right, we should be ready to run this. I'm going to press Control F5. And I've got the sorry too young message. Now this one does have a lot more code in it. So let's try setting our age to, I don't know, 19. And we get can drive and vote. So that looks good. A couple of other things syntax-wise, if you notice here, I don't have a space between the greater than, equal, and the 21. All of those spaces, all that white space is not necessary, but it's really highly recommended because it makes your code more readable. So you could have kind of all of this stuff smushed up together. And in general, the compiler would figure out what's going on. Once in a while, it would cause you trouble, but in general, you would be able to get away with that. So if you're an engineer type who hates to see blank spaces when unnecessary, you can squish it all together if that's what you want. But they recommend that you not. But a lot of people still do. Okay, so I'm going to save all that. I like that one. Let's create one last project that has the select case statement for our age so that we'll have an example of all of them. Before we do that, put our comments in this one. This is a multiple selection if else statement. I don't think there's anything else that we need to say, is there? Multiple options are handled. Getting everybody taken care of here. Okay, so let's create one last one. In our solution, we right click and create a new project. This last one will be our age using our select case. Let's see. Age switch. And I'm going to do some things to fix this project up. First of all, I'll right click on it and set it as my startup. Then I'm going to rename the program.cs to be age switch. Yay, okay. So in our main then, come on, anything. For some reason it doesn't want to zoom. Maybe when I start typing, sometimes that does it. I'll go ahead and start with our age at 14. And we're going to start out with that keyword switch. And following the keyword, then we need a variable name within parentheses that's going to be our switch statement target. And we're going to have open and closing curly braces to delineate our switch statement. For this example, the first one, we're going to say, in case we get 21 through 150. That should get everybody, right? We shouldn't have anybody be older than 150, at least right now. Now we're going to end that selection with a colon. And it's still going to gripe at us. And if you notice, it says that it cannot control fallout. I'm thinking that means we don't have a break statement there yet. So that error should go away as we code that. All right, so for this one, I need to update my using And I want to write out a line that says they can drive, vote, and drink. Please drink responsibly. And then put our break. Still mad at me. There it goes. Took it a second. So take a look at this. It's got a lot of syntax. Remember I said that beginning programmers can kind of stay away from these things? This can be why, because there is a lot of syntax, interesting syntax to remember. The body of my case statement comes after this colon and ends with a break. The lines of code within the body have closing semicolons, right? Because they're just normal code. But the case statement is kind of special, so it ends with the colon. So we can see a lot of special things going on there. Okay, so that is our over 21 case. So now my next case is going to be the people that are 18 through 20. I want to write out and drive and vote. Please vote responsibly. And then break. And then our 16 and 17-year-olds. And drive, please. Drive responsibly. And then we want to break out. Now, lastly, our default also ends with a colon. And we're going to do the same thing in this one, saying, sorry, you're too young. You didn't meet any of our criteria. And we still have to break, even though we're at the very end of our switch case statement. Then that closing curly brace is the end of the switch. So if you look at the code, the if-else clauses that we did are pretty readable, and this is pretty readable. So when other programmers are coming along looking at your code, these are the most desirable options because they make everything really, really approachable to others. Let's test it, make sure it's working right. I'm going to press Control F5. I've got my sorry, too young message. So I'm going to change the age. I'll do 17. Control F5. Oh, I got sorry, too young. Does it not work?
Are you running the right one?
No, I'm not. Yeah, I am. I am. Darn, I wish I wasn't. We're going to have to debug it. So let's set up a breakpoint up here where we declare this variable, int age equals 17. The syntax is right. Is it actually working properly? I've got my breakpoint set. So I'm just going to run my project. Right now, my variable isn't really initialized, so it's set to 0. So I'm going to step into, now my age is 17, and I'm right at my switch case statement. So if I continue and step into, see, it just went all the way to the sorry, too young thing. Even looked like it evaluated the others. So let's change our numbers here. Let's make it be not a range. Let's see if we can do some debugging and get something different to happen. I don't like that the way that's working. So I'll make each of my case statements just a specific number, and I'll change the age to be 16, so it should catch one of those. Now I'm going to start it again. As I step into, my age gets set to 16. Now my switch case statement begins, and it's finding the right one. So, oh my goodness, look how good that debugger is. Do you see how helpful that is to figure out what's going on? I still can't encourage you enough to use it. So it looks like we got some debugging to do there. I'm gonna deselect this. And before we go do that debugging, let's add a ternary if statement or two to this last example that we have. So I wanna do a right line statement. UI, I don't know. How about, let's create a Boolean variable. Bool can drive. So we've decided that if someone's age is greater than or equal to 16, they can drive, right? So we could set that variable to true. Otherwise, we could set it to false. Now, I'm not outputting anything here. And sometimes we get stuff so buried in right line statements that it's hard to see what the actual code is doing. So I just wanted to leave this outside of a right line statement so we could really focus on that ternary if. We're saying here we have a Boolean variable named can drive. In order to set it, we want to look at the age. If the age is greater than or equal to 16, we're going to set that variable to true. Otherwise, we're going to set that variable to false. We'll go ahead and put an if statement in. If can drive, because that's all we need if it's a Boolean variable. Oops, except for those parentheses. It's griping at me. And then I'll put a right line. They can drive. Otherwise, too young to drive. Now on mine, I had an opening curly brace at the end of the if statement that was giving me a little error. So I wanted to show how we could have those lines of code without any curly braces and how we can use a Boolean variable in our if statement. So notice with our Boolean variable, since it already has a value of true or false, it doesn't require any sort of conditional, just the name of the Boolean itself, and that will evaluate to true or false. Okay, so we know that the first part is giving us a little bit of trouble, but right now I have my age set to 16, so I should see that they can drive, please drive responsible, and then I should see they can drive again. So I'm going to try that. Oops. Why do I have build errors? It says type or namespace definition or end of file expected. Well, that means I've got a curly brace problem somewhere, right? Because it hit the end of file and wasn't expecting it. So for some reason, it thinks there's something wrong. So let's see what I've got right here. It's got it highlighted. Can I delete that one? Looks like it. I have extra. Now let's control F5 and see. Probably didn't have that problem. And so first out of my switch statement, I've got the can drive, please drive responsibly. And then finally, they can drive. So that looks good. So let's fix that problem. We have a bunch of groups here. Let's see which group can figure it out first. Why are we not being able to do a range check on this switch statement? How can we change that syntax? It liked it. It wasn't giving us an error. Let me know when you have it, so we all will know what to do. Find it. Remote control, tell us what to do. Let me release it for you. What do we do? I've got myself stuck here. It won't let me let go. Okay. C# is super picky about some of these things. It works, let's say it. It's kind of gross. I mean, like Java just flat out won't let you do switch statements with certain data types. So C# tries, it's just a little gross sometimes. Oh, nice. Awesome. That's definitely interesting. I've never seen that before.
Did you see that on Stack Overflow and Google
Uh-huh.
switch range? Sure, I just saw that on Stack Overflow. Yeah.
Did you see that same? Any others? You guys see any others? Fix it. Thank you. Okay. Before we go. On the main Discord server, disconnect. I'm on a voice channel. I'm probably talking to somebody. Stop it. On the general channel. Dr. Ford has this link to the method conference. It is, I don't actually have it on my calendar, Thursday, March 5th. And what she is saying there, if you notice on Discord, is she's going to pay for some people to go. So right now they decided that student price was going to be half price. The original price is $100. They've knocked it down to $50 for students. And now Dr. Ford's saying she thinks she could pay for some people to go if they wanted to. So if you're interested, send her a message and let her know that you'd like to go. Take a look at the schedule. They have he's been working really hard to bring people in, and so it's all software development. They used to have a conference every year in the fall that a lot of us would go to, but it was more IT, like they were more looking for networking people and people to do PC maintenance and stuff like that. This conference is brand new. This is the very first time they're going to be having it in Springfield, and it's all for software developers. So the organization that's putting it together is that devs group that does the web dev meetups and the .NET meetups. And so they've worked really hard over the years to bring tech into Springfield. That's why there are jobs here, because they've worked so hard to be like, hey, this is a tech stuff. So this would be a really good thing to go to. In the morning, they're going to have choices like you could go to one of 3 sessions or one long one, and then they'll have lunch. And then in the afternoon, same thing. You could go to 3 separate ones or one long one. And there's, you know, like door prizes and food, and that's why I won't go. Take a look if you want to go. Questions? Guys got if statements all clear in your head? We'll do a little bit more practice next time, but not too much really, because you guys are ready to just start implementing them and using them in important classes and things. Okay, questions, get out of here. The new REPL should be open for you. It's all if statements. Let me know if you run into trouble, because if you run into trouble, there could be a problem with it that I need to fix. So do that. Have a great day.
All right.